Assalamu alaikum. We'll be continuing with the part where we left behind in our last lecture. There are certain sums which were given to be done as the homework. So we'll be actually trying to solve them in this lecture. But before that, we're going to learn a few rules about differentiation. Now, differentiation is to be done on, let's say, a certain function or certain equation. It must be in a certain form. So far, what we have learned that works specifically for like arithmetical difference, like arithmetical terms. If let's say the equation is somewhat y equals to mx cubed plus dx squared cx plus d. Like this sort of equation, if it has, previously we saw that when we differentiate them, we tend to implement the differentiation on individual terms individually. Like on each of them individually, we tend to implement. Since there's a constant term, we will place the constant term in front because it doesn't change. And simply we will be differentiating our x cube with respect to x, I mean dx, so writing it with respect to x, plus we'll be differentiating the equation x squared with respect to, there is also a d in front because this is a constant d, over we have to differentiate with respect to x, then differentiation, there is a c constant here, differentiation of x with respect to x, plus we have a b here, differentiation of, here we have a imaginary x to the power 0 plus x to the power 0 is equals to 1 with respect to x. Now when we differentiate them, we simply just get a real sort of value which is somewhat like this, d2x plus c into 1 plus d into 0 into x to the power minus 1, here x to the power 0. So we get the final answer of 3mx squared plus 2dx plus, here since x to the power 0 is equals to 1, so you can just simply write it c plus d times 0 times x to the power minus 1, and we know 0 times anything is equals to not 0, so you can simply just write this part only, which is our differentiated value. Now talking about this, if let's say we have a term, or we have let's say equation in this form, y equals to x squared multiply by multiply with, let's say, root over of 4x plus 6 cube. In that scenario, how are we supposed to differentiate them? See, because here x is in like separate part, and we are supposed to differentiate them with respect to x. Now, if we do need to implement differentiation on this x as well as this x, but if we implement the previous rule, which is to individually differentiate them, like if we want to differentiate them, if we simply like write that we have to differentiate this x squared with respect to x, and we can do, since here they are multiplied with each other, and we implement in this way, like multiplied with differentiation of 4x plus 6 whole cube over dx, then it is actually wrong. Why? Because here we cannot do this, or we cannot proceed this method in the like multiplication or like sort of any divisional work. that is only applicable for arithmetic or simple addition and subtraction method. Okay, so then how are we supposed to do that? In over there are rule comes of, there are certain rules which appears, which like in return actually helps us to solve this sort of equation, which are not like simple looking. Now, the first rule which we learned in our last class is the power rule. Power rule is basically what we have learned so far. So let's say if we have an equation x to the power n, then simply differentiating it gives us n times x to the power n minus 1. So basically we get n times x to the power, x to the power n minus 1. So this is what we get. Okay, this is our power rule. Then we have another rule which is constant rule. Now constant rule, we have seen it in the power rule as well, but still for the formality we can also define it. Constant rule is, if let's say we have a constant as the equation of c, like this is actually y, okay, x to the power n is equal to y, c is also equal to y. So if we differentiate it dy by dx, what were we supposed to do? We're simply doing to differentiate this c or dx, but this c is a constant, but c along with it has what? C times 1. So c along with it has c times 1, and we know 1 is equal to what? C times x to the power 0. So you can simply write c is the constant, so we can bring this constant in the front, and we will simply differentiate that x to the power 0 with respect to x. That should give us the value of 0 times x to the power 0 minus 1, that means minus 1. And we know anything to the power 0, anything multiplied with 0 is 0. Okay, so this is the constant rule. See, this also we learned in our last lecture. Now, if c over here was given as, let's say, y equals to 5, simply the constant rule is implemented. Why? Because we now over here has actually, we do have a imaginary x to the power 0. Now, when we differentiate it, dy by dx, we get 5 times differentiation of x to the power 0 over dx. Then we simply get 5 times 0 times x to the power minus 1. Simply, we should get a 0. So that's our constant rule. Now, in certain, like these are two of the equations, so we can number them. This is number 1. This is number 2. Number 2. Just a minute.